Hello everyone! Ever wondered how your email provider filters out spam with such accuracy? Or how your phone recognizes your face to unlock? Today, we're diving into the captivating world of classification models in machine learning. Classification is a supervised machine learning technique used to categorize data into predefined classes or labels based on input features. Imagine you have a collection of photos, some containing cats and others containing dogs. To build a classification model, you would show the computer many pictures of cats and tell it, "These are cats." Similarly, you would show it many pictures of dogs and say, "These are dogs." After training on these examples, the model learns to distinguish between cats and dogs. Now, when you show it a new picture, it can predict whether it's a cat or a dog based on what it learned. Key characteristics of classification models. Discrete predictions. Unlike regression models that predict continuous values, classification models categorize data into distinct classes or labels. For example, they can classify emails as spam or not spam, images as containing cats or dogs, or transactions as fraudulent or legitimate. Target variable. In classification, the model predicts the class or category of the data point, the dependent variable, which is discrete and predefined. This could be binary, two classes, like spam/not spam, cat/dog called binary classification, or multiclass, multiple categories, like animal species, orange/apple/mango called multiclass classification. Predictive features. Classification models use independent variables features to classify data into different categories. These features can be numerical, categorical, or a combination of both, depending on what helps distinguish between different classes. Supervised learning. Classification, like regression, is a supervised learning method. It requires labeled training data where each data point is assigned a known class or category. This labeled data helps the model learn and generalize from examples. Evaluation metrics. To assess the performance of classification models, common evaluation metrics include accuracy, percentage of correct predictions, precision, how many predicted positive instances are actually positive, recall, how many actual positive instances are predicted correctly, F1 score, harmonic mean of precision and recall, and confusion matrix, a table showing correct and incorrect predictions. These metrics gauge how well the model classifies data based on its training examples. Here are some common classification algorithms. Logistic regression, a statistical method for binary classification that estimates probabilities using a logistic function. Decision trees, a tree-like model that splits data into subsets based on feature values to make predictions. Random forest, an ensemble method that uses multiple decision trees to improve classification accuracy and robustness. Support vector machines, SVM, a technique that finds the hyperplane that best separates different classes in the feature space. K-nearest neighbors, KNN, a non-parametric method that classifies data based on the majority class among its k-nearest neighbors. Naive Bayes, a probabilistic classifier based on Bayes' theorem, assuming independence between features. Gradient boosting machines, GBM, an ensemble technique that builds models sequentially, correcting errors of previous models. XGBoost, an optimized version of gradient boosting with improved performance and efficiency. Neural networks, models inspired by the human brain, including deep learning networks that can capture complex patterns in data. AdaBoost, an ensemble method that combines weak classifiers to create a strong classifier by focusing on misclassified examples. Linear discriminant analysis, a technique that projects data onto a lower dimensional space to maximize class separability. Quadratic discriminant analysis, similar to LDA but assumes different covariance matrices for each class. Each algorithm has its strengths and weaknesses, and the choice of algorithm often depends on the specific problem, dataset, and performance requirements. In summary, classification models are essential in machine learning for sorting data into predefined categories based on learned patterns from labeled examples, enabling automated decision-making in various applications. I trust you found this video helpful. Thank you.